Hi, everybody. This is Robert Hodges, and I would like to welcome you to our webinar on Strength in Numbers, an introduction to ClickHouse cluster performance. Before we dive into the webinar, I'd like to just tell you a few things about how we're organizing this today, which may save you time and also increase your enjoyment of the materials that we're presenting. First of all, this webinar is being recorded, and we will send both the recording as well as a link to the slides afterwards, so you don't have to frantically take notes. It will be available to you after the webinar is finished. Second thing, we have a question and answer box, and we'd like to invite you to pop questions into that as things occur to you. If the topics are relevant to what we're talking about at the time, we'll probably stop, take the questions in line. Otherwise, we will have time at the end to answer questions at some length. I hope at least 10 or 15 minutes, because this is a complex topic and many of the issues that you have won't necessarily be covered on the slides. Finally, at the end of the webinar, when we start the Q&A, I'll be running a poll. We run those every time. The idea is to get some feedback from you on how we did on this webinar, where you're at in your ClickHouse usage, and what other topics you'd like to see in the future. We run this every time, and it helps us make the webinars better for you. So with that, I'm going to go ahead and jump in. Excuse me. So just a little bit about myself. I'm the CEO of Altinity. I'm also a database geek. I've been working on databases of one kind or another since 1983. ClickHouse is about number 20. I also am delighted to say I have with me today our CTO, Alexander Zaitsev. Alexander, do you want to just check in and introduce yourself?
Hi, everybody. It's nice to see a good crowd here. I am CTO and founder of Altinity, and we're making ClickHouse better for you. So I will be helping Robert with some material today.
Yep. Thank you, Alexander. So Alexander will also be making this webinar better, because there's some materials that we'll be touching on here where he has unique experience, and we'll be able to cover them really well. So one more thing before we dive into the material is just a little bit about Altinity. Alexander was a founder of it, and we started out our goal is to make people successful with ClickHouse. We're the leading provider of software and services for ClickHouse, and a major committer as well as a community sponsor in the US and Western Europe. So I'm glad to see that some of the people who are here are already our customers. Welcome. We're glad to have you, and we hope everybody else will follow suit. All right, let's dive in. So in this talk, we're going to discuss performance of ClickHouse clusters. So we'll dig into how ClickHouse, the distributed clusters, are set up, talk about using shards to scale writes and actually reads as well, and then also using replicas to scale read concurrency. So we'll understand what the architecture is, what are the axes that you can use to scale, and then we'll spend a bunch of time just going through tricks and performance bottlenecks and other things that you need to know about distributed clusters to use them effectively. So two things we're not going to do. We're not going to talk about performance of single nodes. We did a webinar on that a while back that's already out on YouTube, very popular, but in that webinar we dive very deeply into particularly the behavior of the merge tree table and how you can optimize performance on a single node. We're going to take that as a given here, although we'll discuss it briefly at the beginning. And so if you want information on that, just refer back to that webinar or other talks we've done. The other thing we're not going to do is teach advanced ClickHouse performance management. ClickHouse is a very capable piece of software. This talk is kind of aimed at people who are sort of beginner to middle users of ClickHouse clusters to help you be more productive. So our goal is to give kind of a general overview, but not necessarily dive really deep into some of the more complex issues. We'll obviously take those as questions. So for those of you that are new to ClickHouse, we always have a few, I'd just like to give you a very brief introduction to ClickHouse. For those of you that have heard me talk before, I often try and describe it as follows. Imagine MySQL, very popular open source database, and Vertica, a very popular proprietary data warehouse, got married and they had a baby. Well, that baby would be ClickHouse. So from the MySQL side of the house, you're open source. You, of course, understand SQL because you're a self-respecting SQL database. You run practically anywhere, and you're pretty easy to manage. So these are properties that you get with MySQL, and at least in the design sense, they have been inherited by ClickHouse. From the Replicas side, you have column organization. You have the ability to vectorize have vectorized execution locally as well as parallel execution across nodes. You have the ability to scale to many petabytes, and you're extremely fast on OLAP queries. So take those two things together and those concepts, and basically that gets you ClickHouse. ClickHouse was originally developed at Yandex. The design started in 2009. It was open sourced in 2016. So from here on out, we're going to take it as a given that you have some experience with ClickHouse. And what I'm going to do now is dive into the ClickHouse cluster model and just how things are organized. So before I get too deeply into that, though, I think it's good to talk about ClickHouse nodes and just understand what's the scaling model that we begin with when we run a single ClickHouse node. So there's basically three ways you can increase the capability, and we call this vertical scaling because what we're doing is instead of adding more nodes, we're actually just going to make the nodes that we have more capable. You can add more memory, you can add more CPUs, or you can upgrade your storage. And storage is shown here as a single axis, but it's more accurately multiple axes because you can obviously scale the amount of storage you have available. You can scale the number of IOPS. So it can scale a couple of different ways. But we can think of those as three general ways that we can change the capacity of a ClickHouse node and basically go from a node with low capacity up to one with a great deal. As we introduce clusters, what we're now going to be doing is, instead of vertically scaling, we're going to be talking about scaling horizontally. And there's two basic ways that ClickHouse does this that are baked into the model and that ClickHouse makes fairly easy to apply. The first is we're going to introduce the notion of sharding. So sharding basically means that you take a data set and you divide it up into separate pieces. So for example, let's say you had a multi-tenant system. You could split it out by tenants and have a node for each one. That's a simple example of sharding, and we'll actually talk about sharding models in more detail later on. Another thing you could do is if you had a very large, if you were doing analysis of marketing data, you could just arbitrarily divide it up into thirds, for example, and put a third of it on each node. So what this does with sharding is it basically adds IOPS. In the same way that when you apply RAID, you can bind together a bunch of spindles on rotating media and get a performance that is the aggregate of all those devices. What you're going to do is by adding shards, you can now write to more data because you have more places to write to. You can read more data because you have more nodes that can help you with the reads. So the other way that we can extend this horizontally is we can add replicas. So having a lot of replicas doesn't really help with individual query performance, but where it is exceedingly helpful is if you have a lot of concurrent users, this gives them more places to go to select data so that they're not treading on each other. So these are two forms of horizontal scaling that ClickHouse supports very well, and they're the basis for when we think about clusters, it's basically extending we'll think about scaling in these two directions. And by the way, there's a question here I just noted for a second. Usually, what are the triggers to move from a single node approach to a cluster approach? That's a really great question. In a nutshell, if you can go single node, it's generally you're going to move to a cluster for two reasons. One is that you think you're going to exceed the capacity. Either you're exceeding it now, or you think you'll exceed it in the near future, say a 12-month horizon. That's a great reason. Another reason, actually, that you can horizontally scale, particularly around replicas, is for HA. So we're not really going to talk about high availability, but that's another reason that people run replicas. Let's keep going and talk about the sharding and replication patterns. So one of the things that's really important to understand about ClickHouse is that when we talk about sharding and replication, it's always at the table level. So we have a bunch of nodes, and they can support replication, they can support sharding, but actually what happens when you look at this in detail is the decisions about which data goes where on those nodes are actually made on the table level. And there's three general types of patterns that you can use when you're thinking about this. One is to have everything be a shard. So, and a good example of this is if you look at the system logs or system tables in ClickHouse, there's a table called a query log, which is exceedingly useful to track your queries. You can think of that as being having a shard present on each table. There's no replication, but you could think of, if you want to think of the query, look at the queries across the entire system, you can think of this as being a bunch of shards that you can then put a distributed table on top, and we'll explain how those work in a minute, so that you can see all of the query log contents across the entire system. So that's an all sharded approach. Another approach is all replicated, which is you can have a table and there's a copy of it present on every single node in your cluster. And a good example of where you will tend to use that is for things like dimensions that are used universally, tend to be sometimes but not always relatively small tables. You'll just put them on every single node in your cluster, and that will allow you to join locally on them, something that we'll discuss later on in this talk. And then finally, you have a pattern called sharded and replicated, where you split the data up into pieces, and then you have some number of replicas for each piece. And this is a common sharding pattern for very large tables. So if you have a fact table that covers your sales or results of sort of events or marketing campaigns, you would use this. Pattern. So break up the data and then replicate it into different pieces. So one of the things that's important to understand about ClickHouse is that there's nothing magic about these patterns. And we call these, you can define these patterns in any way that you want. I've mentioned three general ones, but you can use others. And the way that they're actually implemented is if you go into ClickHouse, there's a file that by convention we call remote servers.xml. It has a remote servers tag, which is part of the configuration of the ClickHouse server. And it is just lists, literally just lists of hosts with different ways to arrange them. So in this particular case, we have a sharded and replicated layout. These are also referred to as clusters sometimes. So we have a shard that consists of these two hosts. There's another shard that consists of another two hosts, so on and so forth. So the clustering pattern is basically what you say it is. And these different types of patterns that I described are just conventions for laying things out. Overall, it's simpler if you keep these, use relatively standard patterns, but you can basically use any pattern or layout that you want to. One final thing that I should mention, we won't talk about replication too much, but I just want to mention what's going on with replication and how it works. So ClickHouse replication is multi-master and it's also asynchronous, which means that if you have a replica and you put data into, load a part or, some number of rows into that replica, what will happen is that will result, there will be a record made in Zookeeper, which keeps the list of parts that need to be replicated for that, sort of moved around for that particular set of replicas. And then the other replicas will, in a short time, notice that it's there, go talk to the original server, grab the part, and pull it back across. So this means that when you're doing replication, or when you're using replication, you can insert into any one of your nodes, and the replica, the data will eventually be replicated out to the to other nodes. There are ways to alter this behavior so that, for example, if you're doing an insert, you can force it to become fully synchronous so that you can, for example, you can set quorum and that will enable you to know on the application that yes, the data actually successfully received hit more than one replica. So that's going on in the background. We won't talk too much about more about the implementation details of replication. We did a webinar back in the summer that you can look up that covers this in quite a bit of detail. Excuse me. So at this point, that's the theory behind the clusters. What I'd now like to move is into the practice, which is where it gets interesting. And so in order to practice on things, it's helpful to have a sample. And for a lot of the preparation for this talk, what I did was I went ahead and I set up one of our favorite data sets, which is the airline on-time data set. We use that. It's about, the copy I have has about 173 million rows in it. And what I did was, normally we run this on a single node because it's really small. It's a great example of something you really don't need a cluster for. But what I've gone ahead and done is actually set it up as a distributed data set, and the way that it is organized, and I've organized it a couple different ways for testing, but basically we have the shards of data, and they're shown here in red. So we have two shards, and they're each replicated two ways, and they're in a table called on-time shard. So that's our that's our chunks of the airline fact table. We have a dimension table called airports that's replicated fully across all clusters. And then in order to get at these and run queries, we have a distributed table called on-time, which will then allow us to both load as well as query data in the underlying on-time shard tables. So that's the basic setup. And in fact, we'll be digging into the details of how the distributed tables work in particular, because that's where a lot of the magic happens for clustering. So just going into the details of how these things are actually defined. For the fact table, what we're going to do is go ahead and create this table. Actually, if you're running clusters, one command you want to get really familiar with is create table on cluster, create database on cluster. What this is doing is it's creating a table called on-time shard. The on cluster means it's going to get propagated across whatever your cluster is defined to be, in this case sharded and replicated. And then we're using the replicated merge tree. Again, if you haven't seen this, what this is doing is setting up an engine and setting a path, which is going to tell, basically, is going to be maintained in Zookeeper, and it's going to be the way that the replicated merge tree can tell where the information is about the state of this particular table and what needs to be replicated. The other types of things, partition by, flight date, order by, these are normal things that you see in any merge tree table. Now, you may have noticed that I used macros. Those are the little things with squiggly brackets. So in order to make clusters work, it's really important to set up macros. These then allow you to use the same definition across the table, across the entire cluster, and ClickHouse will fill in the values. So this is an example of how I actually set those macro values. Now, the next thing we're going to do is create, since we've got the fact table defined with a nice sharding pattern, we're going to set up a distributed table. And so this is a much simpler piece of DDL, because basically we can copy from the schema of the on-time shard table that we set, and we're going to use the distributed table engine where we're going to tell it, hey, what's the cluster that this table belongs to? That will enable us to figure out, okay, what are the where's the data located? What's the name of the underlying, what's the name of the database it's located in, which is airline shards? What's the name of the underlying table where the shard data are actually located? And then the final thing, rand, this function is a partition key, and excuse me, a sharding key. And what this does is when we insert data, it enables the distributed table, if we insert the distributed table, to make a decision about where to put, which shard to put data in. What this is saying is just, for every row that comes in, just randomly assign it to a shard. For small data sets, for small clusters, it's a reasonable way to distribute stuff. And then finally, the replicated dimension table. Again, it's the same replicated engine. This is relatively small, so we partition by tuple, which means don't bother to try and divide it up into parts. And we use a cluster called all replicated, which simply has a list of all servers in the cluster. So with that, we've got our sample data set up. What we'd like to do now is actually insert some data into it and see how fast it is. So I want to give just a little overview of the insertion options. So one really important decision in loading data into a cluster and particularly getting the best performance about it is to decide whether you want to go insert locally to the shards, because these are just ordinary tables, so you can put data straight into them, or you can use distributed approaches. And a couple that are popular, one is to go through the distributed table, so it will use that sharding function to decide how to split the data up. Another thing which we won't touch on, but is more deeply, but is very popular, is to use chproxy, which will essentially load balance the transactions across nodes. So these are two ways of having the distribution of data decided for you by the underlying system. Also, by default, when we insert into a distributed table, that's going to be an asynchronous operation. That's good because you can blast the data in and run off and do something else. However, there are cases where you want to make sure it really got there. So insert distributed sync, insert quorum. These are different options that allow you, first of all, to ensure that the distributed table is not batching things behind your back. And then second, that you can ensure that replication actually took place. For the purposes of this talk going forward, we're going to just be using I was just using the asynchronous default options, but you can, if you care about these are options that you can, settings that you can control to make sure that the data really arrives where you expect it. So let's look at the simple case then of inserting in a distributed manner through the distributed table versus a data pipeline. So if we do the inserts, if we point our data pipeline to the distributed table, we can pick any table that we want, any of these distributed tables, because I made them across the entire cluster, and we just insert in. And what happens by default is the on-time distributed table engine, the underlying table engine, will just grab these inserts. It will break them up using the sharding functions into separate shards, stick them in a temporary location, and as soon as it can, it will then ensure that they're pushed across, actually more correctly I think, pulled across to the right place where they need to land. So what you can see here is it's coming in, it's getting sharded, it's getting stuck in this cache, and then it will eventually land on these two shards. And if you're actually watching, you can watch these files, and you can see them sort of piling up, and eventually they reach the shards and they get deleted off the distributed table. The other way that you can do this is that you can just point your data, have your data pipeline understand a little bit about what your sharding pattern is, and just point it straight at the underlying tables. Because there's nothing magic about shards in ClickHouse. They're just tables, and what makes them a shard, what brings a set of shards together is to have a distributed table on top of it that can see them all. So as a result, many people actually build their data pipelines and just have them go straight to the underlying tables. You just need to pick one replica in each case, blast the data in it, and we'll get replicated out properly to the remaining replicas. So there's some trade-offs in these approaches. When you go directly, it means your pipeline needs to be shard aware. It needs to understand where to put data. On the flip side, if you insert into the distributed table, it's slower because the data are being rewritten, and it can be more error prone, and I'll show an example of that in just a second. So if we go ahead and actually test this, what we're going to see is results that look like the following. So I tried a single shard, and this was basically using the merge tree, so it wasn't replicated at all. I did two replicated shards, or two shards replicated two ways, and I went through the distributed table, and then I went direct loading through to the shards without going through the distributed table. And what you can see is that basically if your system's have lots of capacity, it's about equal loading time for all of these. That's pretty consistent across these data sets. Where it gets interested is as your volume goes up, and the whole reason you're clustering probably is because you have more data than a single node can handle. As we start to increase the load, in the single node case, I loaded up 20 threads, so I could actually push the performance down a little bit and get it loaded faster. When I did it through the distributed table, it crashed. And the reason is that I'm going through the distributed table, I'm having to buffer this stuff, and so it just consumes more resources. And in this particular case, I didn't have enough, and it crashed. That is not, I want to say that is not a big problem overall. Lots of people run things through distributed tables, but it does illustrate the fact that it requires more resources. And then finally, with direct loading, I was able to go and actually get the best performance where I was going to the 2 replicated shards just directly. And of course, if I had more shards, you would see a much more pronounced improvement in loading. So when you are using the distributed tables, you want to be aware that they're somewhat resource efficient because they're double copying the data. And because if they're running asynchronously, there is a chance that you can lose data. So if the shard crashes or something bad happens, it's an async assertion, and you're not guaranteed that all the data is going to reach its location. And then the final thing that I think is worth mentioning is this is something that you definitely want to monitor carefully. So because the actual behavior underneath is not super, it's not super visible to what's going on, so your monitoring system needs to be watching this carefully. Okay, one really big design question that people go through, in fact, I was on a call on this earlier this morning, is selecting the sharding key. So as we're looking at how to how to split up the data across the shards, this is a really important decision, and the experience is that of many large sites is that they took a decision and then they regretted it and had to change it later on. So it's worth thinking about this up front. Basically, 2 general approaches. One is to just randomly shard. So for example, pick some value X, which is in a column that varies pretty randomly, like your whatever your arrival date or something like that, or some other or session key or some pretty high cardinality value, and just run a city hash on it. And then basically what you can do is split it across. In this case example, I'm just splitting across 3 shards. The other way I could do that is, for example, in a multi-tenant system, is if I have a tenant ID, I could just go ahead and take the modulo of the tenant ID and shard things by tenant. So there's definitely trade-offs on here, as you can see from this slide. On the random key, the big downside is that you're typically going to have to query all the shards, because ClickHouse has no way of knowing where the rows went in a way that it can trace back to the to the query. Now, in the case of sharding by tenant, that's not a problem, because you can now begin to skip shards either explicitly in the application, and ClickHouse is beginning to have some capabilities to do that as well. But you're going to get unbalanced nodes, and this is very hard to control, because you just never know how much data you're going to have for a particular tenant, even if they start out the same. Some tenants do well, some other tenants don't do so well or may go away. So you'll have rebalancing issues. And one key thing about ClickHouse is there's no magic to this. ClickHouse does not automatically rebalance data. So what some people have done, and for very large installations, is they've done what amounts to a bi-level sharding approach. Excuse me, where what you'll do is you'll sort of take the top level, and you'll take that tenant ID, and you can shard off the tenant ID, and that will get you a group. And then you can, within the groups, you can use a random approach, which then spreads the data evenly. So the idea is that for some tenant X, they would end up in one of the groups. So at the very least, you would only have to check say 3 servers as opposed to 7 in this example. So this is just a simple example, but this is an approach that many people have used successfully, and it does give you, in some sense, the best of both worlds, because you can now add nodes more easily in the groups, but you also have some ability to control the space that you're traversing when you have to do queries. And just one thing that's important in query performance that you have to keep in mind is that the more nodes that your query touches, the more chances that one of them is going to be slow. And that's going to be, in distributed queries, the slowest node is the thing that determines your performance typically. So trying to keep that number down to something reasonable means that you're likely to have better overall performance. There's, again, no magic, just to repeat something that I think I've said before. There's no magic in the sharding schemes. So if you pick something like bi-level sharding, you're just going to go ahead and add more macros, and you're going to add more stuff in your, you can build out the, the path in the replicated merge tree. Any sharding scheme that you decide, and sharding and replication scheme that you decide to adopt, you can just, implement it by appropriate changes to the macros file, the remote servers, and then these the replicated merge tree settings. So it's pretty flexible. By the way, on bi-level sharding, how to come up with a number which will be used for computing the mod. Actually, this is sort of a somewhat synthetic example. One thing that is what you would do in that particular case is you would basically decide a number in advance for that. Another thing you can do is that could also be a lookup in the front, where you basically just have a map to, you have tenant IDs and then you map them to particular groups. So there's a variety of ways you could do that. It's, again, no magic here. It's just something that your applications will need to understand. Adding nodes and rebalancing data. ClickHouse is not like Cassandra. It doesn't magically move data around. So this is something that as you're building the cluster, over time you are going to need to add capacity to maintain performance if you're adding data. Usually, as we've discussed here, the random sharding schemes do allow easier addition of shards. And in particular, if you have time series data where you keep it, say, for 7 days and then just let it go away, for example, using a TTL, with the random sharding schemes, what you can do is you can just bring more nodes into the cluster, put them in, assign shards to assign them to cover particular shards, and as your time series data arrives, as long as you are correctly inserting, it will just slowly fill up that node, and after the, say after 7 days, if you have a 7-day TTL, all the shards will be balanced. So that's the easiest way to do it. The replication, of course, propagates the dimension tables in this case. If you need to, if that doesn't work, either because you don't have data that conveniently rebalances itself, or you're using a keyed partitioning scheme, you'll end up having to remove stuff move stuff yourself. And that there are no magic tools for that yet. We are working on that problem, but there's various fairly straightforward ways to move data across. One of the big things about ClickHouse is that data is immutable. After a certain, once a part is written, it does not get rewritten typically. So it makes it fairly straightforward to move data around. Let's talk about the other part. So we talked about writes and inserts, and hopefully given you some things to think about and be helpful. Let's talk about distributed queries, and this is where behavior gets really interesting. So in order to get a query to run across multiple shards, we're going to have to come through a distributed table. So the application is going to write to the on-time table, and we call that the initiator node. So it's going to process the query initially, and what it's going to do is try and push down as much of that query as it can. And what it will do is, if you have a query, the innermost sub-select is going to get selected. So in other words, you think about that as your left side of the query. If you have a subquery, will get pushed down, And what will happen in the actual shards is it will compute the partial aggregates, what are known as aggregate state functions. So it'll be able to do counts and things like that, get them into a partially aggregated form. They are then pulled back up or returned to the initiator node, which then goes ahead and merges them. So one thing that you can see here is the more work that has to be done on this single on-time node, the slower things are going to get, the more resources you're going to need. So what you want to do is, to make these distributed queries really work for you, is push down the where and your heaviest grouping work, get that into the innermost query and get that done locally. And then just the results come back to the initiator. And here's a really simple example of this. There was no join in this query, but I ran a fairly thick query that forced us to scan a bunch of columns. And if you do this right, you get linear performance on the number of nodes, which is what this shows. So single shard took about 10 seconds to run the query when it was cold. The second run was hot, so I basically had it set up so that the pages from storage would get stored in the buffer cache. And what you see is you're running 1, 2, 4 here. This is basically linear performance. One thing to notice is that if you have very fast queries, at some point the network overhead is going to dominate your parallelization. So below a certain level, you won't see improvements because you still have to transfer the results around and put them together. But when you're doing this well, the results are pretty phenomenal. So just a little bit about then the behavior is, by default, what's going to happen is you come into the distributed table, and ClickHouse is just going to push down the joins. If you have a right and left join, that will get pushed down to the lower table. You can to the sharding tables. You can see this by going into the query logs. You'll see the initial query come in. It lands in the it lands on the distributed table node, and then if you go out to the nodes that get picked, the replicas, you'll then see the push-down query, and in fact, that's how I got this. And what ClickHouse has done here is it's changed the on-time, which was the distributed table. It just changes it to the on-time shard and pushed it down and ran it there. So another thing that then, of course, is if you don't want that to happen, a simple way of doing that is just to make that left side query be a subquery, in which case that's all that gets pushed down and the join happens later. And in this particular case, that turned out to be beneficial because we were basically joining on these airports, which is something that was just faster to do once we had aggregated the data. So this shows you the push-down effects. Now, at this point, so far that's pretty straightforward. However, there's a number of settings that can further affect joins, and for those, I'm going to invite Alexander to jump on and just talk a little bit about the distributed product modes, how they affect joins, and the effect on in operators.
Thank you, Robert. I will start with answering the question that we have in our questionnaire. So if a huge dimension tables needs to be joined, and you certainly can put it on a shard, but this table is only going to be available at this shard. So in order to use it in a join, you need to replicate it. This is pretty straightforward. The real interesting stuff is starting if you want to join two distributed tables. For example, you have one distributed table and you want to join another distributed table. In this case, it's actually not evident how you want to do it. And Robert, can you show the next slide? Because it's probably better. Yeah. So consider that you have two tables, T1 and T2, and you want to join it, or it's pretty much the same as if you want to do some in condition. In this case, you actually have three different ways how this query can be executed. First, you can run the local table on every node, both T1 local and T2 local, and that will produce you a good result and correct result if both tables are sharded by the same sharding key. And only in this case, if both tables are sharded differently, then you can get a wrong result in this case. Another way to run this query is number 2, when your first table is running in a local mode and the second table is running in a distributed mode. So in every shard, you have to repeat the same query, select something from T2, and that works. You will get a consistent result. But if you have many shards, that will mean that for single query, you will run tens or hundreds distributed queries for T2 that may affect your performance. So ClickHouse has a third mode to run those queries, and in the third mode, ClickHouse would first run a subquery or build a temporary table for the join or not initiator, then pass this data to all shards that should execute the distributed part, execute the queries in there, and return the result. So distributed product mode setting that had been shown on the previous slide allows you to control the behavior. So normally, if you would try to join two distributed tables, you will get an exception because it's denied by default. And the reason it's denied because it's not clear what you want, what behavior is normal, right? And you can alter it using allow local or global setting. And this is just triggers the different ways to run this query. So if you think about that, so in principle, you should always run in a global mode, right? When queries are rewritten, if you have two distributed queries. But in some rare cases where you have some two big tables, for example, and you sharded them exactly the same way using exactly the same shard key, you can run those queries in a local mode. And in this case, your query performance will be much better than in global because you will be joining the pieces of the data on every local shard, and only then results will be combined.
Great. Thank you very much, Alexander.
Yeah, you're welcome.
So, yeah, I had Alexander in because this one is definitely where it begins to get more complex. And in fact, it's really important to understand that ClickHouse does these distributed queries extremely fast, but it's not magic. And so here's just a few things. So if that join table is missing, for example, if you're using the defaults the way I was initially, the pushdown will just fail. It'll push down the query, but it doesn't know that the table's not there, and it will fail. There are some issues with row-level security predicates. If anybody is using them, they're not correctly pushed down prior to 20.1, so that's something to be aware of. That was recently fixed. There are some minor differences in syntax to get things to propagate correctly. The best policy is just fully qualify your table names, and that will, as the things get pushed down, you will then avoid problems where ClickHouse ends up in the wrong database context and can't understand where the table is located. And then the distributed join behavior is limited. There's no distributed query optimizer here. You need to tell ClickHouse what to do and form your queries in the right way. So, if you do that correctly, it's really fast. If you don't, you can get errors and sometimes incorrect results. So there's work going on in all of these areas to improve this, but this is the state of things right now. There's a bunch I won't cover these too much because I'd like to make sure we get to questions, but we already talked about the distributed product mode setting. There are many others, sort of, for example, if you're a MySQL person, you know about replica lag. That's something that we have a setting for that, maximum delay, load balancing, localhost replicas. These are all things that allow us to choose replicas, control how replicas are chosen, control whether we can skip shards, things like that. So again, it goes back to you're giving ClickHouse some hints about how to do the query better and get you the best results. There's some advanced topics I'd like to just go through that as you're, sort of once you have the clusters up and running and you're really putting some load on them. One of the really important things for clusters and ClickHouse in general is to do capacity planning. It's fairly straightforward. It's simpler for small nodes. Often for small data sets, you don't even need to do it because ClickHouse is so fast and compresses really well, so you have a lot of headroom. But as you're building clusters, particularly large ones, it's important to think about this and actually run some tests before you make decisions about things like sharding keys, as well as the size of hosts. And this procedure is largely thanks to Mick Kosakowski at Cloudflare. He did a great talk back in December. But the way that Cloudflare tests is as follows. So when they're thinking about a cluster, the first thing to do is understand the capacity on single nodes. So going back to the scaling factors of CPU, RAM, storage, and in particular, you want to load data on it and get an understanding of what's the local contention between things like inserts, your background merges, which are merging your table contents over time so that they can be queried most efficiently, and selects. So, if you have very high levels of inserts, and your parts are too small, for example, some of you have seen too many parts errors, you want to get that stuff solved before you go to a cluster. And then just understand, what are the basic scaling issues like, marked cache sizes and things like that you should have covered at the single node level. Now, one thing that's nice is that you may find that for the nodes that you have, you don't need a cluster. So if you can see, like, if you have a 12 or 24-month design ceiling and you see, hey, it's a single node will do it, great, just stop there. The one thing you want to think about, of course, is high availability. So you're either going to have to do backups or you may need to introduce replication. But in this case, you don't need to do sharding. Now, if you do need to do sharding, at that point, you build a cluster, and then you test the full capacity. So you're going to jam as many inserts as you have on it, and then see what you need to do to support the write capacity. And you're also going to layer on selects, and particularly if you have a lot of concurrent selects, you'll need to add replicas to get a reasonable level. The key here in doing this kind of capacity planning is to use your own data. Synthetic data does not do the job. You can't generate enough of it, and it doesn't have the variability that you really need to get good results. Slow nodes can be a problem, and there's various ways that systems can be slow. In fact, in setting up for this talk, I had a storage performance problem on Amazon. And a great trick is to use the remote table function. If you need to see what's going on across the cluster, you can run queries using the remote table function. And this is just an example of where I'm running the same query across different nodes to see what the performance is. And that's a quick way of diagnosing, hey, there's one node that looks like it may have problems. Obviously, monitoring systems are really, really important to be able to see if a node has particular problems, but sometimes there's no help for it but to actually just run against the tables. And in fact, in general, there's a number of things that can go wrong in clusters. For very large clusters, Zookeeper can be a bottleneck if you have huge numbers of parts. So that's not a big problem. Systems like users like Cloudflare hit it, but it's not common in smaller installations. They're running like 120 plus nodes. So choosing a bad partition key, this is something that is hard to get out of, because what happens is you discover it's bad. Usually you have a lot of data, so you have to move it around, and ClickHouse doesn't magically move it. So you may have at some point to redistribute your data manually. Systems degrade. This happens both temporarily and permanently, so you want to be on the watch for that. And related to all of these, not having enough monitoring will just kill you. So I would definitely, in fact, in setting up for this talk, I didn't show it, but I had a huge amount of monitoring installed just so that I could see what's going on across the cluster. You cannot go in and be logging in and looking at logs. You need to be able to see graphs, you need to have visualizations, and you need to see data over time. So there are other things, but this is just stuff you should plan for. So with that, we're done. We're going to get into questions. Let me just wrap up really quickly. So shards, they give you read-write. They basically add IOPS. So you can think of them as adding read-write capacity over a data set. The replicas for performance enable more concurrent reads. Sharding keys and clustering patterns, ClickHouse allows you to do it any way you want. So you need to think carefully about what's the right design for your application, and the choices are almost always going to be dominated by what your application needs to do. So inserting directly to shards over time, that is the way that gets you the best performance. So as opposed to going through a distributed table. That said, many people still use distributed tables and are perfectly happy. The distributed query behavior is definitely more complex than running on a local merge tree. So there's a number of settings here, but you really have to tell ClickHouse what you want to get the right results. And the last thing is that when you build a cluster, you're building a big distributed system. Stuff is going to go wrong. So you need to plan for that and be ready to deal with it. So for example, have lots of replicas, because if one goes bad on you, you've got a replacement. Have lots of monitoring so that you can see what it's doing. And test on data so that you're not surprised by obvious problems. And one of the key lessons, I think, is that if you do the clusters well, they're really fast. So if you're not seeing fast results, like for example, if you set up a distributed table, you run queries on it, and it's not, for example, twice or 4 times or 8 times faster than running on a local table, there's something wrong. So what you want to do is check your setup to find out what's going on, because typically the problem is not that ClickHouse is doing a bad job. It's just that either something's wrong with your resources or you don't have it configured correctly. And speaking of resources, lots of other things to read, just suggested here. The Secrets of ClickHouse Query Performance is the webinar I mentioned before. We also have a bunch of other webinars, including replication, so check them out. And this talk by Mick Kosakowski was his name is misspelled. It's supposed to be a W. Really wonderful description of how to do capacity planning at scale. And so definitely check that one out. And with that, we're done. What we're going to do is go over and answer some questions. I'd like to go ahead and launch the poll. So for those of you that are hanging in there with us, please go ahead and fill out those 3 questions. They'll take you about 15 seconds. And while you're doing that, anybody wants to know more information about this or consult on their cluster, we're happy to do an hour free consultation. Just give us a call. We'll jump on the phone and help you, sort of look at your cluster, help you understand things you could do better, and also, of course, figure out ways that we could help you in the longer term. So go ahead and just, the link is shown below, or send information to info@altinity.com, and we'd be delighted to help. So with that, I think we'll turn it over to questions. Alexander, to start off, you had a number of answered questions. Are there any there that you'd like to go back to and talk about verbally? I think you had, I see 11 in the list. Alexander, are you there? I think you may be muted.
Yes, I'm there. I tried to answer questions, so probably we can ask audience if there is something that they want to be discussed in more detail. Yeah,
we've got a we've got a great one from Nitin. Have you seen this message in production regarding replication? So that's on the open questions. And while you're looking at that, yeah, and so a number of these questions, these are great questions. So for example, can you have multiple layouts, like all sharded, all replicated, and mixed? Absolutely, and Alexander answered that. How to remove unreachable instances. This is actually kind of tricky. Is sooner or later you may need to go and clean up some data in Zookeeper. This doesn't happen too often, but yeah, if you need to remove a node, you have to go get rid of the Z node that represents that. So there's work going on. There's work going on to handle that. Cleaning up things in Zookeeper is just way easier if the replicas are still alive. That's fairly reliable. Alexander, did you have anything on that error message? Did you want to comment on that?
Yes. So this error message says that ClickHouse couldn't fetch some data from one replica to another because, but there is no data loss or whatever. So it may indicate that there are some network issues, some temporary network problems, and so on, but this is nothing to be worried about. You need to look into system tables like system replicas and replication queue and Zookeeper exceptions and stuff in order to set up proper monitoring. And only if something goes really wrong and you see it in monitoring that you have some counters to be increasing and so on and so forth, you may dig into logs in order to see what's actually going on in there.
Okay, I got another question coming up here. SSD versus HDD, will the query performance be worth the cost? I can answer that one. Yes. So do you mean that? And so there's a couple ways. The couple ways it can be answered, but absolutely, SSDs are hugely have a huge impact if, particularly in the cases where, like, you have a lot of concurrency or otherwise need to get query results back very quickly. There's a different set of issues, though, that come up with SSD versus HDD. And a big problem that people have had in the past on scaling is that they had to pick one or the other, not both. So, for example, if you wanted to go cheap and have high density data so that you could have long retention times, you had to go HDD. If you wanted very high very high query speed and a lot of concurrency, obviously SSD are better. That problem, if you're thinking about that trade-off, one thing you should definitely look at is tiered storage, which allows you to put your hot data on SSD and then your cold data on HDD. That's stuff that's now available and getting a lot more stable in version 20. Let's see, Alexander, if a replica node is temporarily switched off, oh, I think you may have gotten it.
Yeah, I already answered that. No, if
you can go ahead and answer these live.
Yeah, if replica goes down, this is certainly a good scenario that you may face in a production environment, and there is nothing to worry about. As soon as replica is up, ClickHouse will make sure that the data has been replicated back. So, what other questions we have?
Yeah, so will ClickHouse cluster benefit overall over a single node for a lap table with 5K updates per second as well? So that one's not clear. Do you mean that, okay, updates, you're actually changing the table? I'm not, because clearly with inserts, that's not a very high number, but if you're, so you can update, I mean, you can go ahead and do updates. One of the things you will see, of course, is that they'll need to replicate across. And updates and deletes are asynchronous. They come in the background. ClickHouse processes them, and they are also then in replicated setups. Of course, they're going to have to be applied on all replicas. So there's actually not a huge, Alexander, correct me if I'm wrong, but there's not a huge difference in performance because the basic cost is to go rewrite the data. So if you're doing an alter table update, you're going to have that cost no matter what. And since with replication, it's basically going to happen in parallel, there's not going to be a huge difference in the impact.
Yes, so you can update a massive amount of data in ClickHouse in a synchronous way, but you cannot do a lot of single point updates like you do in Cassandra or in Mongo. This is just not going to work with ClickHouse. ClickHouse is an all-up system, so it's designed to operate with the batches of the data, not with single rows.
Great. We had a question. Can you revisit, show the use of remote to see individual CH server response times? There it is. You know, another thing about remote, it's a really handy function. You can put more than one name here. It's kind of, so it will effectively create kind of like a dynamic, like an on-the-fly distributed table. So just comma set, you could have ClickHouse 0, ClickHouse 1, and you would actually see the results from both of them at once. It's actually really handy. You can add host name in. It's a very, very handy way of seeing what's going on a bunch of servers at once. What tools do you recommend for cluster monitoring? I think we recommend a lot of them. So our standard stack is Prometheus plus Grafana. We have the most. We use that a lot. It's very popular in the ClickHouse community. So they definitely have that, but you know, beyond that, you can use Zabbix. You know, you can use Instana. There's a bunch of monitoring solution. I think the key thing is like, what are you comfortable with, and what gives you the completest picture. So for monitoring, it's important, particularly in these clusters. Don't just monitor ClickHouse itself. You need to monitor the whole node. So whatever gets you that is probably your best monitoring solution. Let's see. Oh, you've got one, Alexander. The parameter for configuring the pool name for HTTP connections. Go ahead.
I actually pressed the wrong button, so there is no
okay.
parameter for that. So we don't. I'm not sure what you're asking about.
Yeah. So, okay, got a couple more here. Will replicated data be affected in terms of data loss when Zookeeper goes down and Zookeeper persistent data is deleted? Do we need to back up Zookeeper disk? Alexander, you want to answer this one? It's a very sad topic.
Yeah, so basically you need to keep Zookeeper safe. If you lose Zookeeper, it's possible, but it requires quite a lot of manual work to restore your cluster to working state. If Zookeeper is down, ClickHouse goes read-only. You can still run queries, but you cannot insert any data. Once Zookeeper is up, everything should recover. If you lose any data in Zookeeper, then you need to recreate it. And in order to do that, you basically need to manually reattach all ClickHouse tables and make sure that they are re-replicated, and the data in Zookeeper is restored. So just for you to understand what Zookeeper keeps for ClickHouse, it keeps all metadata about all data parts and files that are stored in the file system. And this metadata is used in order to synchronize replicas between each other. Zookeeper doesn't keep any data, only metadata, right? But it's important. At the same time, we don't recommend to backup Zookeeper because you cannot make it consistent with your data anyways. So if you backup Zookeeper and then you restore it, it's already not the same data that you have in your ClickHouse file system. So there is very little reason to do that. So instead, you should just to concentrate on making it safe. If you have free Zookeeper replicas, it's normally very hard to lose it.
You can also put observers on other sites. We don't go into this, but there's definitely DR patterns that you can follow. I have a question about Kafka ClickHouse engine, stable in the latest ClickHouse version.
Yeah, so use latest 1916 if you are looking for the most stable ClickHouse version at the moment. It's 1916.19, and Kafka works pretty reliably here. In fact, we're preparing an article to our blog on Kafka, which it's kind of Kafka frequently asked questions, and just check it out from time to time. It might answer a lot of questions on Kafka.
Okay, I think we're going to, we're over time, so I think we're going to go ahead and close up. As somebody noted, the poll actually didn't ask for the future topics. That was a surprise to me as well. Normally it does. I need to double check that. If you do have things that you'd like to see, feel free to send us email at info@altinity.com. We hope you enjoyed this webinar. I learned a lot doing it. And Alexander, thank you so much for your help today. It's great doing webinars with you.
Likewise.
Great. Okay, great. If there are further questions, go ahead and send them to us at info@altinity.com. Oh, here, what about duplicate? Here, we can handle one more. John Prakash, what about any duplicate or data corruption that can occur during the inserts when there's a latency either in shard or replica side of Zookeeper? That's a hot, so.
Let me take this one. So yeah, this is a very interesting topic. So ClickHouse has support for data deduplication, and it's based on Zookeeper. And it works like as follows. If you insert exactly the same data twice, then ClickHouse just can silently ignore the second insert. The rationale for this solution is that sometimes if you insert data and have some network problem, you cannot acknowledge your client that the data has been actually inserted. And for reliable insertion, the typical approach is to retry on the client side if you got some network error. But when you got a network error, you do not know if the data has been inserted or not. So once you retry, ClickHouse makes sure that the data hasn't been inserted twice. It only works if you insert into replicated table and insert exactly the same data. And ClickHouse keeps by default 100 last inserts. So you can actually retry after a certain amount of time, and it still will work okay.
Great. I think we're going to call it a webinar. Thank you so much, everybody. Definitely send us questions to info@altinity.com if you'd like to follow up on this. We'd love to hear from you, and if you have further questions, we'd be delighted to answer them. We will see you at the next webinar. Thank you very much. Have a great day.